right, here we are back at Algebra 3-7, consecutive integer problems, and this is example 2. Find 3 every other even numbers. Woof. Every other even numbers, giving the following. If you double the sum of the first two, it is 18. Okay. So, first thing we need to start with are some let statements. I'm realizing that they're asking me for 3 numbers here. They want 3 numbers. So I'm going to have 3 let statements. So first number equals, second number equals, and third number equals. Okay, so now just like in the last example, I used the numbers 2 and 3 up here as an example to kind of help me make sense of things. I'm going to do that same thing with this one. So 3 every other even numbers. So let's kind of talk about that. 3 every other even numbers. So let's list out some even numbers. 2, 4, 6, 8, 10, 12. If I was looking for every other even, I would be skipping one. So I wouldn't go 2 and then to 4. I would go 2, skip 4, go to 6, skip 8, go to 10, skip 12. So 3 every other even numbers could be something like 2, 6, and 10. Now remember, I'm using those to help make sense of what's going on. 2, 6, and 10 are not answers to my question. They are in no way, shape, or form related to my answer at all, except for the fact that they're even numbers that are every other. But I'm going to use those to help. Keep in mind that you're still always going to have an x. Let's put that in purple. There will still always be an x. There's always going to be some expression that is just an x. So that first number we don't know, we're going to have that be x. Okay, so if my first number is like 2, what do I need to do to 2 to get to 6? Or what do I need to do to x to get to the, not the next even number, but the skipping an even next even number? That made no sense. So focusing on what do I do to 2 to get to 6? Well, 2 plus 4 gets me to 6. So my second expression is going to be x plus 4. Okay? And so then, what do I do to 6 to get to 10? That's another plus 4. So x plus 4 plus another 4, which just simplifies into x plus 8. So now that I have those expressions set up, I am going to create this equation that I have here. So if you double the sum of the first two, so sum means I'm adding the first two. So x plus 4, that's the first two. Doubling that would be parentheses and multiplying that by 2. So double the sum of the first two numbers. It is, that's my equal sign. It is equal to 18 more plus 18 than 3 times the larger. So this third number is naturally my largest because I'm adding 8 to it, and that's the biggest number. So 3 times the largest number would look like 3 parentheses, that largest number. Then 18 more than that, plus 18 at the back. So now you just need to go ahead and solve that equation. Do some simplifying, do some math there. So 2 parentheses, that's going to be 2x plus 4 inside the parentheses. Distribute the 3 to both pieces. 3x plus 8. 8 times 3 is equal to 24. And then carry down that 18. Doing the distribution on that other side, 2 times 2x is 4x, 4 times 2 is 8, 3x, 24 plus 18, 8, 9, 10, 11, 12, 3, 42 on that side. And now you're just continuing on isolating that variable. Subtract your 3x to both sides. 4x minus 3x is just a plain old x. Get that x by itself by subtracting 8 to both sides. 42 minus 8 is 40 minus 6, which is 34. So we have x is equal to 34. Keep in mind, though, that we have not found the answer. We did not answer this question. So if I use the fact that x equals 34 to go back and solve and find those three numbers, my first number is equal to 34. 34 plus 4 would give me 38. And 34 plus 8 would give me a total of 42. So my three numbers, the three numbers are 34, 38, and 42. Boom.